Hi guys, this is Ms. Miner, and we are going to do lesson 4C. And today's goal is to be able to find the y-intercept from a graph and from an equation. So up to this point, we've been kind of just focused on the m part, or the slope part of our equation. And we've just kind of been focused on this part that's circled here in yellow. And so today we are going to make a switch over to the other number in our equation, which we found is represented by the variable b. And we say this is the beginning of our graph. We use the variable b because this is the beginning of our graph. And when I have a story problem, in a story problem, we looked for certain words that represented our b value. Starting amount, fee, we said it could be initial value or an initial amount. So in a story problem, we said that this number is represented by those words. Well, in math, we use the variable or the letter b to represent this number, and we call it our y-intercept. And it is where x is 0 and y is a number as an ordered pair. It's the place where x is 0, so it falls right on the y-axis. It is going to be a point somewhere on the y-axis. And so we'll talk about that today. And so this number is all of these things. These are all representations of this number that we've been putting in this box. Okay. So let's go ahead and find the y-intercept from a graph. And the very first thing that we need to do when we have a graph is find the y-axis. So if we find the y-axis, I've highlighted it here in yellow. Here's my y-axis. It's the axis it's the vertical line that's right in the middle of my graph, and it's the one we've been labeling y. Usually it's the one that has the numbers assigned to it. Not all graphs have numbers, but you guys should be pretty familiar by now with labeling the y-axis and finding where it is. The y-axis is the one that is running up and down like a thermometer in the middle of my graph. So the first thing I want to do, step one, when I want to find the y-intercept, is start by finding the y-axis. Then I want to find the point where my line that I'm interested in. So let me highlight the line that we're interested in here. Here's our graph, or our line that we're interested in. I want to find the place where it crosses my y-axis. That one point, that place on the graph where those two lines cross, that's my y-intercept. So that point right there is where x is 0 and y is -1. That is my y-intercept. And I write it just like an ordered pair because it does. It represents a point on the graph. So finding y-intercept from the graph is fairly easy. And so all I have to do if I have a graph, sorry, I just had to check something. I want to make sure that I'm going in the right direction here. Okay, so all I have to do if I want to find the y-intercept on a graph is find that one point right in the middle where my graph crosses my y-axis. And that place, that point, that ordered pair is always going to be where x is 0. And y is going to be some number. If I had a graph that was crossing up higher, right, then my y-intercept would be a bigger number, right? If I have a graph that's crossing at a lower point, let's just draw some graphs in here, right? Then my point is going to be a smaller number. So any graph, I can find the y-intercept just by looking at the y-axis. Okay, from an equation, here is the number one most important rule. I always have to get y alone. My equation has to look like this. It has to be in what we call the slope-intercept form. Oh, now I've spelled it wrong. I want it to be y equals mx plus b, or y equals blank x plus blank. It has to look like that in order for me to be able to tell what the y-intercept is. So we're going to practice a couple of equations where we have to actually solve to get y alone. But once I have my equation, make sure you highlight this or circle it in your notes so that you don't forget. The very first thing you always have to do is get y alone. Solve your equation so that y is by itself. And we did that in Unit 2 when we were solving equations, when we were solving literal equations, and we had to solve the equation to get y alone. And I'll help you with that in just a minute. We'll remind ourselves how to do that. But for now, once I have my equation in slope-intercept form, I have y by itself over here on one side. Then all I have to do is I have to find the number that comes after the x variable. It's the one that's not paired with my x, right? It's my phi number. Or we said it was phi, or a starting amount, right? That number over there, the one not paired with my x, that's my y-intercept. So from an equation and from a graph, it's fairly easy to determine what my y-intercept is. Okay, let's practice. Let's first find the slope, okay? And then let's practice. Let's first find the y-intercept, okay? So I've already kind of got you the ordered pair started up there. So now all we have to do is look at our graph, identify where my y-axis is. Here it is. It's this one in the middle that goes right down through the center. And then I have to follow along, right along my red line here until I get to the spot where my y-axis crosses. And so that spot right there is where x is 0 and y is positive 2. There's my y-intercept right there. And I could fill it in over here in my equation, because we also know that in my equation y equals blank x plus blank, right? That number goes in my second blank. Now we've already learned how to find the slope, so we can find the slope of this line. We can use our y-intercept as one of our good points that we need in order to be able to find the slope. And then we can use any of these other good points that are on the line here. We draw in our rise and run. We count our rise. Here is a rise of 2 and a run of 1, 2, 3, 4. So my rise over my run would be 2 over 4, which is just 1/2. This is a graph that is increasing as it goes from left to right. And so my slope is a positive slope, and I can answer all of the parts of this question now. I can write the equation for the line, y equals 1/2 x plus 2. That is the equation that represents my line. And it is the equation that represents this graph as a whole. So we can kind of start putting some pieces together here. Okay, let's try again. Here's another graph. The first thing that I want to do in order to be able to find the y-intercept is identify the y-axis. Then I want to look at my y-axis and see right where my line is crossing. And in this one, again, my line's crossing right at 2. That was easy. Same as the other one, right? And so the first thing that I want to do is identify my y-intercept. We did that. We filled it in our equation, and we wrote it as an ordered pair. And the next thing I want to do is be able to find the slope. So I can just pick another point on this line. Let's find another good point on this line. Draw in our rise and our run and count up 1, 2, 3, 4. Our rise is 4. 1, 2, 3, 4. Our run is 4. And so my rise over my run is 4 over 4, which reduces to just 1. But the last thing I always have to do is look at my graph. And this graph definitely is going down from left to right. We always read a graph from left to right. And so I need to make this be a -1. There's my slope. This is a decreasing graph. Its slope is -1. Its y-intercept is +2. Okay, so now let's take a look at an actual graph that's talking about something. Be careful about our scale here. Each box here represents a value of 4 every time. Each box on this side represents a value of 20 every time. So we want to make sure that when we count our slope and our y-intercept, we make sure we look at our scale and know what we're counting by every time. Okay, let's identify our y-intercept first. So I have to find my y-axis. Here it is. There's my y-axis. And I want to find the point where my line is crossing. Right here, my y-intercept is where x is 0, y is 60. And then I want to find my slope. So I have to find another point on the line. Draw in my rise and run. Count my rise and run. But this time, every box is worth 20. So that's 20, 40. My rise here is 40. My run here goes by 4 every time. So that's 4, 8, 12, 16. So when I do rise over run, I get 40 over 16. And then I want to look at my graph and find out what kind of slope I have so I know if it's positive or negative. And so I'm going to take a look at this graph. And this graph is going down. And so this is going to be a negative slope. And then I just want to reduce it. So 40/16 is going to reduce to 5, let's see, 8. That'd be 5 over 2. So, let's do this. -5 halves. So my slope here is -5 halves. My y-intercept is 0 and 60. And it says, what does the slope mean in the context of this problem? So gas in the tank, gallons per mile. Gallons per mile. I'm losing 5 gallons of gas for every 2 miles I drive. That's not good. 5 gallons of gas for every 2 miles that I drive. So that sounds horrible. We don't want to get that kind of gas mileage. But that's what it's saying. I'm losing 5 gallons of gas for every 2 miles driven. Yeah, we definitely don't want to get that kind of gas mileage. That would be bad. But essentially, that's what. Now, what does the y-intercept mean? That's not one of the questions here, but what does the y-intercept mean here? Well, it means that I started with $60 gallons of gas. Remember, my y-intercept is my beginning amount. It's my starting value. It's my initial value, right? And so that number right there is the amount that I started with, the amount of gas in the tank when I started. Okay, let's do another one. This one is movie tickets and cost. So let's find the y-intercept. The first thing that we always do is identify our y-axis. Here it is. And then I look to see where my line is crossing the y-axis. And so my y-intercept is where x is 0, y is 6. Then it wants me to find the slope, so I need to identify another good point on my graph, and I can just choose any other point. I just need 2. I draw in my rise and run. My rise is 2. My run is 2. 2 over 2. And so if I look at this graph, it's definitely increasing, so it's positive. My slope here is 1. What does the slope mean? Well, it means that my cost goes up by $1 for every... Oh, I'm sorry. Do you know what? I did not even... I've made a huge mistake. Oh my gosh, you guys. I've made a huge mistake because I didn't look at my scale. This is going by 2 every time. This is going by 6 every time. Oh, so when I count my rise and run, this is 6, this is 12, this is 2, this is 4. I can't believe I made that mistake. I apologize for that, but I'm glad I caught my own error. I was thinking it didn't make sense what my slope was telling me. So my rise was 12, my run was 4, so my slope is 3. And we're talking about cost per ticket. So there's $3 per ticket bought. $3 per ticket. That's what my slope is telling me. That my cost is $3 per ticket. Oh, that makes sense now. Okay. What does my y-intercept? It means that my starting amount was $6. So maybe I already had purchased some tickets, or maybe I'd already spent $6 on like some popcorn and stuff like that. So my cost had already started at $6 before I started buying tickets. Okay. And this is what I promised. I said, okay, we're going to find the y-intercept from an equation, but first we're going to have to solve for y. And it's been a while since we've had to do this, so let's just review, first of all, our steps for solving any equation. I want to get rid of any extra x's that I have. And this is always an add or a subtract step. And these are the same exact equation solving steps that we used back in Unit 1 and Unit 2. The second thing I want to do is get rid of any extra hostages that I have, and that's always an add or a subtract step. And then the last thing that I want to do is get rid of the number that's connected to the variable that I want. We used to want to solve for x, but in this one we want to solve for y. And so whatever my variable that I'm interested in getting by itself, this is the number that's connected to the variable I'm interested in. So I'm interested in y. I want to get y alone. So the first thing that I have to do is get rid of any extra x's, or we could say extra variables. If there's any variables that I don't want, I have to get rid of those first. And so over here, I have to get rid of the 2x first, because that's the variables that I don't want. Here's my line down the middle. I'm going to subtract off 2x's since it started out as a positive 2x's. And since I subtracted it from one side of my equal sign, I have to subtract it from the other. Over here, these are going to go to 0. And all I'm going to have left on this side is 3y. And over here on this side, what's happening here is this one is a plain number. This one has an x on it, and so they cannot be combined. So I'm just going to leave them separate, negative 2x plus 3. And I usually put the x variable first on these because that's how I want my equation at the end. I want the x variable to come first. But it doesn't really matter what order I put it in as long as I can tell what my y-intercept is at the end. All right, so I got rid of my extra x's. Then if there were any other numbers over here, like say I had a +2 or a +4 or something over here, I would get rid of my extra hostage next. But this one doesn't have an extra hostage or an extra number, so I can skip this step and just go on to the last step. Get rid of the number connected. And this is always our divide step. This last step is always our divide step. And so I just want to divide this side by 3. But because I'm dividing, I have to divide this side by 3. And when I divide multiple terms, I just divide each individual term by 3. If you'll remember, that's kind of what we did in Unit 2. I hope it's starting to come back for you. And hold on, I just want to move this down so I have a little bit more room here. Okay, so I divide each individual term by 3. This term is going to cancel. Those 3's are going to cancel, and all I'm going to have left is the y. Over here, -2 divided by 3 doesn't divide evenly, so I just leave it, I just leave it the way that it is. And then 3 divided by 3 is 1. Well, now this is in slope-intercept form, right? So I'll kind of put those boxes up there where they belong, right? Y equals blank x plus blank. This would be my slope. This would be my y-intercept. And so now I can find the number that represents my y-intercept. Okay, so we're just going to, if you don't have this written down in your notes, or if you don't remember it from Unit 2, that'll be a good thing to make sure that you write in your notes and have in your notes. Let's try again. Let's do another one. Okay, 3y equals 15x minus 12. I want y alone, and so I'm really just focused on this y. Remember, my steps are, if I have any extra variables, I get rid of those first. I call them my extra x's, but it could be any other letter that I'm not interested in. And I use add or subtract to do that. I get rid of any extra hostages. And that's always add or subtract. And the last thing that I always do is get rid of the number that's connected to my variable. And that's always divide. So looking at this, there's no extra variables out here or extra numbers to get rid of, so I can just skip over those steps. There is a number that's connected to my variable, and so I just go ahead and divide by the 3, and that means I have to divide each of these terms by 3. This one's going to cancel, and so y is equal to 15 divided by 3 is 5x, and -12 divided by 3 is -4. So my y equals blank x plus blank, right? Oh, this doesn't fit as good as the other one does. But there's my y equals blank x plus blank. My y-intercept is always the number that is not connected to my x. And so my y-intercept in this equation is -4. Okay, that is all we have for today. This is just another practice problem that I give my students who are here in class. But if you're watching the video and you have any extra questions that you need to ask or any clarification that you need, make sure that you check in with either me or Mrs. Zeider. Make sure you're taking good notes, and good luck on your assignment.